just kind of some ground rules at first, where this is typically a longer program than 2.5 hours. So I'm going to try to move quickly through this today. I know you're going to have some questions, and there is a chat. So every now and then we'll stop and just take a look at those questions that you might have in the chat. Do keep this in mind. Most of what you're going to ask, yeah, we're going to cover anyway, because we're going to cover everything from A to Z. So if you want to hang on, if you have a question, be sure to write it down. Make sure you do ask it, but keep that in mind too. That most likely we will be, covering the question that you're asking. This is Mike and I. Okay, I'm in more Eastern. I'm in Downingtown, PA. Mike is in Camp Hill. We cover the same territory, the same ground. So either one of us are available for questions. There's going to be, and I'll point it out, there's going to be a screen that you may want to take a screenshot of that will show SpacePak Presale Support and also the technical support numbers. Those are really your first line of defense, but should something not be working, if it gets beyond that and you need some extra help, we're certainly available to give you that extra help. So today's class, as David had mentioned, there's an extended 5-year warranty that you get, that your customer will get, provided they register their equipment and their equipment is installed by a certified installer, which is why we're here today, to certify you, and that will give them that 5-year warranty. All right, the most important thing that we're going to do today is to go through the installation, go through the equipment, and make sure that you know the differences between SpacePak and conventional systems, and you know how to properly size, design, and install SpacePak systems. So the biggest thing that you get today is a clean installation that works without any problems. There's also the opportunity, as we were speaking of, the opportunity to be included on the website, the dealer locator website. That's a separate form. We're going to post that as well. And also from that, there's lead generation. And in the document to sign up for that, SpacePak asks you to commit to answering any leads that you get. Right, so we don't want to put them out there and then have them not followed up on. So that's all part of it, is that we're sort of depending upon you when people call in, write in, and want to talk to a contractor about a SpacePak system or have a SpacePak system replaced, that you do follow up on those leads. We've got marketing support always, and there's something that we can handle for you through Pierce Phelps, and you also get pre-sales and priority technical support. So as a certified contractor, they have your number. You show up as a certified contractor when you call into pre-sales support or the technical support. Now, I do want to say that SpacePak is also going to a support platform, which is going to make things even better there. So we're looking forward to that. I don't have the details on that yet, but that is coming. This is the lead registration form, right? So you would fill this out and get that back to us, and we'll get you registered on the website. And here's what the contractor map looks like. I think most of us have seen these and know how they work. You punch in a zip code, you give it a radius, and all the contractors within that radius come up. So you have the opportunity today to be involved in that. Equipment registration became effective back in February 2021. Right, so if you're not aware of that, you've been installing SpacePak systems that haven't been registered, do go back and register those. It can be done by the homeowner. There's always that question: does the contractor does he register the equipment, or does he leave it to the homeowner? My thought on that is the contractor should do it, because then he knows it's been done, and he doesn't get that call 2 years, 3 years down the road with the homeowner wondering why they don't have a warranty because their equipment isn't registered. So always best for the contractors to register. How do you register? It's let's skip one here. Well, you go to SpacePak.com. We'll see a sample of that coming up, right? So the registration would give you 5 years parts warranty, not labor, and any other warranties would be the the discretion of the contractor. All right, there are some other warranties listed on here. Just want to mention that there's a whole nother side to SpacePak, and that's the air to water side. If any of you are doing baseboard heating or infloor radiant heating, you can do that. You could do it with a hydronic coil that we have, and chilled water. We have a whole nother side to SpacePak that includes the hydronic side. Okay, that takes a different certification. You aren't certified for that today after taking the small duct high velocity certification. So just keep that in mind, and we'll see in a couple of slides coming up that we do have classes online conducted by the factory as well. Right now, there's a waiting, line for that. So sign up, get on the wait list. If you have anyone else in your company that isn't going to be able to make it today, and you want to get them certified as well. Okay. Non-certified contractor on the small duct high velocity receives a 1-year parts warranty. Certified contractor receives 5-year parts warranty. So I think we've pretty much explained that. Here's where the warranty tab is on SpacePak.com. It's easy enough to remember that URL, and it's a easy site to navigate. And one other thing I want to point out is right next to where it says warranty there, technical library, all the documents that you need, manuals, installation manuals, and sales information as well is all in that technical library. So do remember that you can go to the technical library and download documents that you might need. So it's simple. Click on warranty registration, takes you right in, and you can warranty the equipment. Again, installs must be registered for the extended warranty. So that's 2 things: installed by a certified contractor and registered in the warranty process here online. All right, take a shot, take a screenshot, take a picture with your cell camera of this particular screen. Okay, Presale Support, these guys are great. If you have any odd jobs, odd things that you want to run by them, you can do that. You can do that in conjunction with us if need be. There's a team of application engineers there. They'll tell you if what you want to do is going to work. It's pretty easy, the SpacePak system to install, and the only thing is that it's different. All right, so this is one of those products where it's as easy as pie, but different than conventional systems, and you have to know the differences going in so you get it right. All right, so this is available to you, Presale Support at SpacePak.com. Another thing, I might be jumping ahead a little bit, but um, SpacePak has been listing their certifications on AHRI.org. Okay, so the efficiencies and the ratings of the SpacePak indoor units with various outdoor units is populating on AHRI.com. And if you don't see a, a match that you want to look at, you can email presalessupport.com. They have the software to certify a unit, providing it does meet the standards, which is 12 at this point for 12 SEER at this point for small ductile velocity. Once they do that, then they will go ahead and put that listing online as well, since they already have it done. So do keep that in mind. The other thing is technical support, right? So pre-sale support is before the sale when you're laying out a job, and technical support can be reached at either technical service at spacepak.com. If you're leaving a job, you want to shoot those guys an email and go back to the job the next day, that works beautifully. Or you can call the number there, showing there 413-564-5530. That number is also on every single document. You know, it's on the installation instructions, SpacePak's phone number. They have a very easy menu. I think it's number 6 on there for technical support. So technical support is when you're on the job, you've already got the equipment, or if you're going back to a job later on because there's technical problem with the job and you have to fix it. So keep these numbers and emails in mind. All right, so these are the monthly trainings. These are at spacepak.com where we saw the warranty tab. There's also a tab for training. So you just click that tab, scroll down, and you'll see courses that you can sign up for. As I said, right now they just had a run of courses. There's a wait list right now. You can get on the wait list. There's small courses. I think it's about 20 people, only for certified installers or for installers who want to be certified. So only for contractors. And there's both the small duct high velocity course and the hydronic heat pump chiller course as well, which is separate. Okay. All right, web-based, run by the factory, contractors only, and the do register early or get on the wait list because they go fast. Coming soon to a SpacePak near you. SpacePak will be shipping units with a new finish or a lack thereof. All right, the cabinet will be made of a sheet metal that's infused with zinc, aluminum, and magnesium. All right, so it's a new sheet metal product that is impervious to rust and resistant to scratches. There's no need for paint or for touch-up. So most manufacturers are using pre-painted steel out there. And the problem with pre-painted steel is that when you cut it to make panels, you expose the steel on the cut edge, right? So this is not an issue with this metal, with this product. And we just want you to know about this. It's an improvement. We did not forget to paint your unit. This you'll recognize it now when you see it as the new, as the new metal that they're coming out with. All right, SpacePak. No unsightly components. Right, it's very aesthetic. Less requirement for expensive renovations because we can fit our duct work in smaller areas. It just provides comfortable, and we'll talk about that, even temperatures with less stratification. It's energy efficient, quiet, comfortable heating and cooling. I'll try to point out some inherent energy efficiencies with this product that don't necessarily calculate into a SEER rating or an EER rating. Okay, we're talking about electric and BTUs when we look at those ratings, but we're not looking at the duct per se, and we're not looking at lack of stratification, with more heat, moving through the ceiling into the attic with a hot ceiling. Okay, so there are some inherent energy efficiencies that go with this system, and they don't show up in the ratings. There are a number of options with SpacePak that allow the systems to be installed just about any home or building if you're doing a small commercial application with this as well. All right, we've got, as I said, a complete other side, the hydronic side, and we've got various options: electric heat pump, straight air conditioning, hydronic heat in conjunction with any of those options, chilled water cooling or DX cooling. So it's a very versatile system, and that gives us some arrows in our quiver that we can use to, do a job and figure out the best way to do it. Okay, the duct that we use is 9 inches round. It could be 8 by 8. Anything 64 square inches, we'll cover that in more detail as well. All right, so in a typical 5-ton duct, and I think that's actually a little bit small there, 9 by 21, we can fit 2 of our 9-inch ducts. So we can put 10 tons of cooling in the space that we would normally use on a conventional system for 5 tons of cooling. So that's one of the advantages that we have, is that we're going to use less space for our duct work, and we're going to with that be able to do more jobs, do those jobs that don't have enough space. Now there's an inherent energy efficiency right there, is that we have less duct area, so we have less heat leakage or heat absorption and cooling through our duct surface, less surface on the duct. All right, and on the 2-inch tubing, all right, on a 2 1/4 by 10 duct wall stack, for instance, we can fit 5 of our 2-inch ducts there, which is equivalent to about 10,000 BTUs. So we've got 2,000 BTUs in cooling versus 10,000 BTUs in cooling in the same space. These are some differences between SpacePak and conventional system. We're at about 1.5 inches water column static pressure, maybe just below that. If we get up above 1.5, then we're getting to the point where we probably should have more outlets, or shorter outlets. And if the way we compensate for longer outlets is to put more outlets in, and we'll cover that as well. Conventional system, about a 1/2 inch of static pressure. We're at 220 to 350 CFM per nominal ton. I'll tell you right now, because I like to put this number out there, 250 is the sweet spot. Okay, 220, you'll see a lot of our charts will have 220. The ones that I couldn't change yet because they're graphics and not editable. I like to put 250 in there because 220 is the minimum, and we never want to shoot for the minimum. We want to shoot for the sweet spot. Okay, so just write that down in your notes. 250 CFM per ton is really what you're looking for. Sometimes we can go a little bit higher than that in some instances, which would typically be a retrofit application. If we can get 220, then we're going to be okay. We're just going to have a noisier system and more marginal than at 250 CFM per ton. Conventional system, as we all know, 400 CFM per nominal ton. We've got a 1700 RPM motor on the SpacePak system. We've got a 1050 RPM motor. All right, so we have more rotations, and you'll see as we go through here, we have a 10x6 wheel, but it's a backwards inclined wheel, and it can handle the high static that we are looking to achieve in our ductwork. So we get all sorts of things coming in, but we've had guys wonder why they couldn't put a standard standard air handler in place of our system. God knows there are probably guys out there who have tried. The problem is those standard air handlers will not operate up to the static pressure levels that our unit will operate to. All right, and then also our motor is an ECM fan motor X13. Okay, but we're controlling that though as a variable by the signal that we send, the volt DC signal that we send to that motor. Okay, and we'll talk all about that as we move forward here. Okay, equal pressure on all sides of that balloon at 1.3 inches water column. All right, so that was blown up to 1.3 inches of water column, and that pressure is exerted on the entire inside area of that balloon. And if you've looked at the gas laws, they explain that as well. All right, we do the same thing with our ductwork. All right, so we use a process called static regain to blow it up like a balloon. All right, so we have no pressure coming out the building up in the duct here until we put a cap on the end of that duct. When we put a cap on there, what happens is we have a rebound back up the ductwork. All right, and with that rebound, we fill that entire duct with static pressure. All right, which is 1.2 to 1.5 inches water column. All right, so it reaches all the way back to the air handler. If we're jammed up, we don't have enough outlets, we actually back into the fan, and that's when we have problems. Okay, so again, if you're over 1.5 inches of static, then you got to look at possibly putting some more outlets on that system. All right, so we've got high pressure, and the example here says 1.3. There's a range; it doesn't have to be 1.3. We've got high pressure. That pressure turns to a velocity of about 1,500 feet per minute with the proper number of outlets on our system through the 2-inch tubing. So we've got a high velocity coming out of the tubing. All right, and that translates to about 40 CFM per each outlet. And we'll see this in writing. We should have it in here, but that's about 2,000 BTUs per outlet in cooling, and about 3,000 BTUs per outlet in heating. And we're going to use those figures to determine how many outlets we need in a room. We're still working with BTUs here. That's what we do, okay, and in this industry. And so at some rate, we need to translate how many BTUs do we need to how many CFM do we need, and that translates in our case here to how many outlets we need. Okay, so we're still talking BTUs and CFMs. All right, static pressure check. Where you would check that static pressure would be 18 inches off the blower. All right, it says max 1.3. You could be at 1.5. All right, in a properly designed system, the static pressure is going to remain the same throughout the system. Okay, if it's not, then we've got some problems, probably old duct, too small of a duct, or an inadequate number of outlets. Okay, now keep this in mind, the 18 inches off the blower. That's going to be a straight area, and we'll see um, as we move through this that we, with the rules of the road, we'll cover all of those. We're going to have 18 inches out of the blower before we have any fitting, whether that be a T or an elbow. The other thing I want to mention here is that on the new system, the J Plus series, the board itself is measuring the static pressure, okay? But I would still go back in and actually check just to verify that it's showing the proper static pressure that we're seeing in the ductwork. Specifically, I would do it if we have an electric heater, if we have a heat pump, or if we just wanted electric heat. We do have electric resistance heat that we can add to these units. They're added on the outlet of the unit, and they do have an effect on the duct static pressure. So at some point, you may need to take a look at what you're seeing beyond that and sort of compensate for that in your settings in the board. So keep that in mind. I would always check it with a manometer as well. You could have a kink in the plastic tubing that goes from the pitot tube coming out of the unit at the outlet of the unit. That is hooked by plastic tubing into the port on the board that measures the pressure, right? So always measure your pressure anyway. Our conventional systems, we depend upon throw and diffusion and return air. We depend on room air changes to move our air around the room. In this type of system, if we have a ceiling register as shown here, that's great for cooling. It's not very good for heating. All right, and likewise, when we have them in the floor, that's great for heating, but not very good for cooling. Diffusion and throw is more important in that aspect, right? So where we put the registers in a conventional system is not good for both applications. But what we use to move the air in SpacePak small but high velocity systems is a process known as aspiration. All right, so aspiration means sucking. All right, so if you're watching your favorite medical show and the doctor tells the operating team to aspirate, that means they suck out all the stuff. Okay, a little bit gross, but just wanted to give you another example of the word aspiration or aspirate. When we do this, we have a slight negative pressure. Okay, we have, right at the outlet of the 2-inch tube at our outlet. Right, we have a negative pressure. That negative pressure pulls in the room air and feeds it into that stream, that high velocity stream that's coming out of the nozzle. So we use a different different process to move air around the room. Now what that gives us is less than 2-degree temperature differential within the room. Okay, so we eliminate most of the stratification in a room. And as I had mentioned before, we're even on a hot ceiling, and we're not convecting heat through the ceiling into the attic and out of the room. So that's an inherent efficiency that we have within our system. We can use these outlets that work the same in any location, whether in the floor, the ceiling, or horizontal. Aspiration still works the same way. That's another advantage that we have. All right, and so The J series is the air handler we have now. It's actually J plus series, but we're going to talk about the J series a little bit here. The one preceding the J plus, because there are lots of those out there, and you should know what the differences are between the J series and the J plus series. Okay, so this diagram shows you where we're at in the system. This is a very good diagram to use. I think we have this in the downloads along with a chart of the basic system. All right, this chart is a good chart to kind of go over what you have written down on your bill of materials for a system, because you can just look at this and say, yes, yeah, I've got the filter grill, I've got that duct, I've got the unit, I've got the plenum adapter, I've got my lengths of pipe, I've got my T's, I've got my 90s, I've got all of my takeoffs, I've got all of my installation kits. Excuse me. So it's a good diagram to kind of just check yourself with that. All right, so we've got a short return. We use a centralized return. We do have some return. We don't depend on that so much to, move the air around the room, but we do need a return. So we have one. Now, we also like to say that, we use less air, or we have less CFM, but we need every bit of that CFM. It's actually more critical because we have less CFM to play with in our system. So keep that in mind as well. All right, all of the air handlers come in 3 different sizes. All right, 2, 2.5, 3, 3.5, and 4 and 5 ton units. These are available in horizontal and vertical configurations. They are dedicated horizontal or vertical, so they can't be converted. And also we have a hot water coil available, and also we can do this whole system in chilled water too, and we have a chiller line available to facilitate that. So a lot of arrows in the quiver, as I said earlier here. But this, there are some things that I want to point out here that are important. All right, the first chart there, if we look at the electrical characteristics, 230 volt, 60 hertz single phase. All right, these are 230 volt units. They are not 208, 230. And what the difference is, or one of the aspects that we need to look at, is that if we're doing a commercial job at 208, which is predominantly where you would find 208 volts, the board is looking for 230 volts, and it has some leeway in there. But at 208 volts, it sees that as low voltage, and goofy things start happening with the control of the unit. What we recommend there, if you look under that first chart, unit includes optional conversion kit to 115 volt. If you're doing a commercial 208 volt system, you want to convert to 115 volts and put this in, as a 115 volt unit. All right. The other thing on the end of that first table there, minimum SEER 13 plus. Don't get crazy and put 16s, 17s, 18s on these systems. All right, we've got a 12 SEER minimum that we have to meet with the DOE rules that are out there now on a small duct high velocity system. A 14 is fine, 15 is good, but I would encourage you to go into the literature for the unit itself, the outdoor unit that you're going to match up. And we talked about AHRI matchups and how you can get them if they're not showing in the AHRI. We talked about that. Always look for the unit with more BTUs. Okay, a lot of times if we have a higher SEER unit, we're to get that higher SEER, they're sacrificing a bit of capacity. All right, so you might have a 1 3/4 ton compressor on a 2 ton. Look for the highest nominal VTU. All right, and the other thing is that we're going to be somewhere in the neighborhood of the smallest air handler. So if it's a 2 ton unit, you've got a 24 nomenclature in the air handler number for the manufacturer. It's the simplest X13 air handler. That's about where we're going to be. All right, we have a 6-row deep coil, but we also fit that 6-row deep coil in a small space. All right, so that's about where we'll be as far as efficiency goes. And if you look in the bottom chart there, again, they're using 220 CFM per ton as the nominal tonnage or nominal CFM. Okay, I would stick with 250 CFM per ton. You want to be higher than 220 because we never get the complaint that we have too many CFM on the system. All right, so we want to try our best to shoot for that 250. There's that wheel diameter 10x6 with it's backwards inclined, and it's the same blower on every one of those units. So what we've got is a greater speed and more cabinet to move the air through as well, so we can get more CFM through at those same pressure drops. 6-row coil, we'll talk about that a little bit more in the TXV as well. I talked about this, the AHR certified, they're populating the site. Still the bulk of applications are cooling applications for SpacePak, though we're doing more and more heat pump applications. But that makes their priority to get what they can up in cooling ratings. So you'll see more cooling ratings only, excuse me, on the website there. But as we move along, it'll be also populated with heat pump ratings too. Excuse me. Okay. Now we'll move into the the features of the. Let me just move ahead a second. Okay. I think we're going to be talking about these both at the same time here. All right. The J Plus series has an advanced control, and again, we also want to talk about the J series too, because the J Plus is only 2 years old at this point. All right, the J Plus has a 2-line display for easier setup. We'll see a picture of the board coming up, and high efficiency EC blower motor. It is mode specific adjustable, so we can have different speeds for cooling, for heating, cooling stage 1 or 2, heating stage 1 or 2 fan, even during defrost, or if we're going to do humidification, we can have that run at a separate speed. Okay, so it's very versatile as far as being able to control the speed to what we feel is going to be the best speed for that particular application of the air handler. Heat pump compatible, works great on heat pumps, although we do need a little bit more airflow, so we look to get 8 outlets per ton. On heat pumps, we'll talk about that in more detail as well. Chatlav thermal expansion valve that we ship installed. Our competitors ship it in the box, all right, packed separately. 6-row copper aluminum coil, slide out blower. It's slide out blower, but I will warn you that the duct has to be removed for that blower to slide out. So just keep that in mind. and insulated gray cabinet. Again, we do have a new cabinet finish, a new metal actually, that will be unfinished because it's not susceptible to rust. We have that coming up. It has its own float switch, mold resistant primary drain pan, and it comes with anti-vibration foam strips as well. Also comes with a trap, right? Because we need a deep trap since we're on the negative side of the fan. Right, nothing to talk about. We're not going to give you a test on the dimensions here, but what I want to point out is all the way to the right, that 14 1/8 dimension there. That dimension is by design made. This unit is made to fit between two joist spaces on center. So I think we got about 14 1/2 inches in between two 16 and center joists. This was originally made to cut out a return hole, really, and the unit will slide through the hole in the ceiling that the return grill will eventually fit into. It's all designed that way, and then you can push this up into an attic, climb up there, do the install. Last thing you do is climb down and pull that return duct down, connect that to the return air grill, and push that grill up into place and secure it. So that's where that 14 1/8 comes from. That also is related to why we have an oval flange on our unit, because we don't have a lot of height there, but we do want an adequate amount of return air space. So if you were wondering, that's why. All right, the vertical fan coil units, pretty much the same stuff. I don't really need to go through all those different features there, but I do want to point out something: is this is not changeable in relation to the side of the unit that the return is on. If you look in there, you can see a little bit on this picture, that coil is slanted, so we need to come in on that side, that right side of the cabinet, to flow air over that coil. Now, what I have seen done out there in the field, and it has worked, is to put this up on a box if you can't return on this side, and run that box, a furnace box, for instance. But the only problem there is that you need to make sure that you have a smooth elbow transition up and into the return on the side of this unit. All right, we only have a 1/4 inch of static pressure to work with on the return side. Right, and if you look on the back of your duct calculator, you'll see differences in equivalent feet of duct on the different fittings, and just a box underneath there is a pretty high pressure drop, so it's a pretty high equivalent length of duct. So you should really have a 90 that turns and has turning vanes in it if you're going to do that, but it's possible. All right, as you'll see over to the right there on the bottom, 16 1/8 inch. We don't have that same 14 1/8 on this unit, so it's not going to fit between two ducts or two joists anywhere. But it's made to go into a closet or in the basement and flow air upward. Okay, this is the J series board, and I know it might be a little bit confusing. We have J and then we have J plus. Just figure first we had J, and then we put a plus on that. So, and what you see here is up the top we say boards with the S on it for a reason. We've got the center board there, the main board. And we also have over to the left of that, the center, what we call the EVO board, right? And we'll see a picture of that coming up as well. that's where we adjusted the speed on this. So we did a lot of things manually on the J series units that we now do on board, literally, with the J plus series units. Okay, and one of those things that was that we set up that EVO board for heating 1, heating 2, cooling 1, cooling 2, and fan only through little rheostats, and you'll see those in the pictures coming up. Basically, what we were doing is we were setting the volts DC, and we were measuring in volts DC, and we were setting the volt DC signal that would be sent to the motor head, 0 to 5 volts, and that would control the speed of the motor. So we had to do that manually. We had to look at a chart that will come up and determine where we needed to be as far as the signal that we are sending to the motor head. Now, another thing that I want to point out here is that on the terminals on the bottom of the board, we see some T terminals, Y1T, Y2T, W2T. Those T terminals need to be used. We want to wire to the board from the thermostat, and then we want to wire to the outdoor unit through the T terminals. If we use those terminals, we're protected by the freestat. If we don't, we're not protected by the freestat. So that's one thing to keep in mind if you're looking at one of these J series units. Make sure that the outdoor units are wired through those T terminals on the board there. All right, here's a picture of that EVO board. So if you look all the way on the right-hand side of that board, there are tabs, that you would use your meter on to measure the volts DC. There's a common one down at the bottom, and then you would measure each of those little rheostats for stage 2 heating, stage 2 cooling, etc. And you would measure the volts DC and adjust it with a control screwdriver to set the speed for that particular mode of operation. Okay, and this is the chart that you would use to determine what volt DC signal you needed to send to the motor head. Okay, we've got CFM and pressure. We'd have to look at the two of those and find the spot on the graph that corresponds with both of those, and read the line above it for the volts DC. All right. So, for instance, this is a 4 or 5 ton unit. If we wanted to be at 1250 CFM on this, we would look at 1250 on the bottom, draw the line up to that 1.3 static, and that would tell us that really we want to be for 1250 at 5.0 volt DC signal, and we would change the rheostat to send the signal, and we can measure right on those little tabs what that signal is, and that's how we would determine what signal we want to use to run the fan at that particular speed for that particular mode. Now, it's all in chart form down below as well. So there you can either look on the graph or look at the chart to determine what you wanted to run. I'm going to run through these a little bit here, and there's a point on this particular chart here is that these units come from the factory set about in the middle. Okay, so if a guy installed one of these and you're out on it and it's set for 2.5 volts, maybe they never changed it. Okay, but they they needed to change that if they wanted, for instance, 2.5 ton, and they really wanted to be at about 625 CFM, then they really should have switched it up to 3 volts. All right, so that's how you use these charts. So again, that was the J series, the J plus series. Again, we've got more features and benefits on this that you used to have to do manually, but now you can do through the board. We have a digital display screen. That's going to display operating mode, CFM, percent speed, static pressure. Excuse me. The speed can be controlled either by static pressure, or it can be controlled by percentage of speed. Okay, so for zoning, for instance, you can actually have the unit reduce its speed if you're transitioning to a single zone of operation. You can follow that pressure if you want. So this is something that we do on larger units. It's pretty amazing to me when I think about this smaller residential unit that we have that capability on. It's a great control that they have in there. All right, simpler wiring, less components, and more options, as we'll see when we explain some of those connections on there. Easy load matching, because we have a lot of play in what we can do with this, and temperature sensors, thermistors, for delayed fan operation. So our fan delay on the J series, we had a dial for a fan delay. Always make sure that's set. The systems out there that have problems, the delay's never been set. They've got too much static on the return, and not enough supply air. And we always seem to have, all of those things that are wrong with the system when we've got problems with the system. Okay, so we're also IAQ friendly here as well. And we'll talk about those temperature sensors in this frame here. All right, so 24-volt hookup to the right there. Our fan harness plugs in right there where it says fan. Our jumper for 120-volt operation comes shipped loose with the unit. So if you do want to use 120-volt, then follow the directions to use that jumper. It's very easy to do with that jumper. We've got the pressure transducer. All right, so we've got a tube running from a plastic tube like we use on a manometer, running from the pitot tube at the outlet of the unit over to this pressure transducer. All right, so make sure that tube is not kinked, bent, etc., that we're getting a good reading on the air pressure at that pressure transducer. Leaving air and coil temperature sensors come on the unit, but only coil 1 comes on the unit. So we have a leaving air temperature comes on every unit. We have coil 1 comes on every unit. Coil 1 is the DX coil, or in the case of the hydronic model, it's the chilled water coil. All right, coil 2 we add if we're using a hot water hydronic coil. All right, so when we order that hydronic coil, we need to order an additional sensor as well that we're going to use to sense the water temperature in that delay through the board here before we bring on the fan, so that we bring it on with a warm coil. It doesn't come with that coil. I've been asked, when did they just ship it with the coil? Some coils are still shipped out for the older models as replacements or whatever. So we just have to order it at this point, order the extra sensor thermistor for coil 2. And I'll give you a little word about coil 2, W2, and heat pumps, and with electric heat. Okay. Blower coil, blower speed control harness. Okay, That's where the motor head hooks up to by the wiring harness. That's where the volt DC signal was sent to the motor head to tell it how many times it has to turn per minute. The LCD buttons are below. That's where the setup is. There's a link in the handouts. There's a sheet that has a couple of links, but you can just Google it. SpacePak has a great YouTube channel, and they've got some great videos on there about how to how to install the ducts, the 2-inch ducts, how to install the plenum takeoffs, etc. It's worth the while to take a look at those, and you'll learn some things that maybe you thought you knew and you didn't know. On the setup, it's definitely recommended to go in and watch it. It's about a 12-minute video. Find it on the internet. Use that link that we attached in the downloads today. That shows you. That's a lot easier to watch this being done. It's a little apprehensive in the book. All right, so the book's kind of something you revert to once you already know how to do it. Is the way I look at it. Watch that video if you're setting up your first one, and it'll make it a lot easier on you as far as the setup goes. It's really pretty simple. It looks a lot more complex in the book. Once you see it being done, you'll see how simple it is. Excuse me. All right, so on the left side of this, we've got the thermostat inputs, okay? And then along the bottom, we have HVAC outputs. All right, so these are where you'll run to your units, to your electric heat, and humidifier, etc. Auxiliary contacts. You can program if you want to bring something on. I use them as a workaround for having an old zoning panel and thermostats that wouldn't bring on my electric heat at the same time as my heat pump. So those are there. Use them how you need to use them or not use them. You guys can get pretty creative in the field. You're used to doing that every day. So they are there, and just know that you can program which contacts to come on. There's a default, but you can program which auxiliary contacts will come on depending upon the mode that you're in. The float is hooked up from the factory. ERV input, humidistat input, and DFS is defrost. All right, so that's typically W coming back from your heat pump, telling the unit that it is in defrost and you want to bring on the electric heat. All right, so I'm gonna go off a little bit of a tangent here, and I'll try to do it quickly. All right, there's a new board being made right now. Okay, we're up to version 4. There's a version 5 board being made now through input from the field, including my input when I put my heat pump in. There were a couple things that they're changing. All right, and but one thing I want to point out is that when we make to that DFS, the electric heat is actually brought on through W2. So you want to use for your electric heat, W2 down here. Okay, W1 is actually, and keep in mind that up in New England where SpacePak's located, their main offices. Up there, they're heavy-duty hydronic people, and they don't run heat pumps and auxiliary heat at the same time that often up there. They they get to the point because they have a lower design temperature up there, where they cut to backup heat, and typically that's hydronic. So this W1 terminal down here at the bottom is really looking for a signal from this coil 2 sensor. Okay, it's looking to determine, well, hey, when should I bring the fan on? You know, when is that coil going to be a warm coil, and I'll bring the fan on at that point. So on electric heat, always use W2. Now, there were two things that the board did that they're changing in the new board. Number one, the board would not allow running heat pump and auxiliary heat at the same time. I have an inverter heat pump. Mine runs down to 5 degrees, and it gets a pretty good COP at 5 degrees. So I'm still getting an advantage of running the compressor. Okay, I want that to run at the same time as what I'll call my backup heat, or really, I'm sorry, my auxiliary heat. It's not just backup. I'm expecting my compressor to still be running in conjunction with my auxiliary heat that I'm adding to that. And I also want it to run a defrost. When this board receives a DFS signal over here, it's telling W2 to issue a 24-volt signal to the electric heat. So I'm gonna run my electric heat on W2. Okay. Now, to get around the board not wanting to allow Y2 or Y1 or Y2 at the same time as W1. Basically, you're going to take from this bottom level, I'm trying to get my pointer working here. You're going to take Y1 and you're going to move it up here to the thermostat contacts. So what that does is it bypasses the board for Y1. And this goes, you know, from the thermostat directly to the outdoor unit and says, hey, bring on Y1. But what it does, though, when we do that, is it also bypasses the freestat, capability in the board for when we go back into cooling mode. Okay, so this is a temporary fix. Let us know if you're using a heat pump and you want to run both your electric heat and your compressor at the same time. Let me know, or Mike. We'll get you on the list, and once that new board's available, it's in testing right now, we'll get you a new board that will allow both the operation. Now, when you do bypass Y1 here, it basically is running on a W1. It senses W1, and the speed that it's running on is whatever you have set for W1. So just keep that in mind. You need to have an adequate speed set for W1 or W2 in the selection in the unit. Now, there's one other thing that the old board did that they're eliminating is that, and I saw this with my inverter unit starting at a low speed, which is what they do. They go through a sequence. I had my coil heating up, wanted it to heat up to 87 degrees, my DX coil, bring the heat on, so I started moving warm air. What would happen is that I would pull in cooler return air, and there would be a temperature drop in the leaving, actually in the coil temperature sensor. And if we dropped 6 degrees, then the old board would figure, hey, there's a problem here. I'm going to cancel the call for heating. All right, so the new board will not do that. We won't have that drop. It'll continue to run. So just a couple of things here that have come up in the last months or so that I wanted to let you know about. Okay, so we've basically gone through the J+ board here, and no need to kind of cover the same stuff here, so we're going to skip through that. All right, a few words about heat pumps. I mentioned earlier, 8 full outlets per ton. All right, we are the condenser, if you will, in heating. All right, so if we don't have an adequate amount of airflow over that hot indoor DX coil at this point, then we could run the risk of going out on high head on our on our compressor, on our outdoor unit. Okay. All right, hydronic backup, W1, W2, electric backup for auxiliary heat. That's on W2, as I mentioned. All right, and then this kind of covers that for both heat pump and KW switch Y1 output, board output to the thermostat input, and the air handler will run it at the W2 speed. All right, so and then what we need to do is eventually change that board out. So figure that in as well. Okay, I think I pretty much, this is just a diagram of those terminals. They pretty much covered that. All right, so we've got a 6-row coil. We're typically between 25 and 28 degree temperature difference across the coil. That colder discharge allows for lower volumes of air movement. So we have less CFM, but we have cooler air. And we have that moving at a high velocity through the system. That's how we get those BTUs to where we want those BTUs. We've got more coil service because we have that 6 rows team, so we have greater humidity removal. And this also goes back to picking the unit that gives you the most BTUs and not necessarily the highest nominal SEER rating. Less of our BTUs that we remove are going to be sensible. All right, so we have better dehumidification. That means that we've got more latent heat removal, but we do want to make sure that we're going to cover the sensible loads in our home or building. Okay, so just make sure you're not shorting yourself on BTUs. Look at those readings on the unit and side on the unit that has more BTUs is closer to the nominal tonnage. So we remove 30% more moisture, unfortunately, of course. And excuse me. This is an inherent efficiency that does show in the SEER rating as well. All right, more moisture removed. Theoretically, the customer would feel temperature or would feel more comfortable at a higher temperature. Okay, because there's a lower dew point in the in the room or the area in the house or the building. All right, and dew point is really what the factor that really makes us feel uncomfortable, how much humidity is in the air. All right, so inherently they should feel more comfortable. All right, TXBs. This probably shows some old stuff here, but just to let you know, we have chat-lift fitting, so it's a mechanical fitting. If you do have to change the expansion valve, it does come installed. This is a J series, maybe even older, and I can tell that by the right picture that insulation right there on the front of it. That is actually the freestat on this unit. Now we do that with the board. We used to have a separate freestat right on the coil, mounted right on the coil. Okay. All right, so usable for both heat pump and cooling. Again, we give you a trap. use that trap. It's deep enough to compensate for being on the negative side of the fan. All right, so just keep that in mind. We need a deep trap, and and if we don't have that, then we can. What the unit will want to do is pull air up through that trap and not allow proper drainage. Additional heating and cooling. All right, so we've got hydronic coils as shown to the bottom left there. We also have electric heat packages as well. All right. This is the new EEH. It's a direct mount electric heater. It mounts directly up to the air handler. It's available in a wider range than we had before of KW sizes. 2 kW. I'm not sure where you'd use that, maybe on a ton and a half, but if you didn't have a lot of auxiliary load. 5 kW, 7.5, 10, 15, 20. So it's more similar to what you'd see on conventional systems as well. There's a couple of things I want to talk about with this. All right. This is also available. The installation instructions, depending on when it was shipped, may not say it, but this is also available to be mounted vertically on top of a vertical air handler. And it can also be used in line, but to use it in line, you're going to have to adapt the entering side, which is meant to mount right up to the air handler. What goes on this outlet end that you see in the picture there is the plenum adapter that you would normally put on the outlet of the air handler. So you still need that adapter. You just, instead of putting it on the air handler, you put it on the end of this. All right. There's another point I want to make, and this is the EDH model. Okay, this was an inline model. You can see in that drawing there that there's a 9-inch round collar on both sides of this inlet and outlet. This is not compatible with the J series units for board versions 1 to 3. Okay. And well, I can go back and show you. I don't think I have another picture of the board coming up, but there was a signal that the J series board, not the J plus, a signal that the J series board gave when the fan was running. It's some kind of DC voltage signal, so it wasn't, a matter of just adapting that with a relay. That signal was for airflow. The new direct mount that we just covered has its own airflow switch in it, so it doesn't need that. The old J series, and in conjunction with this, used a signal, a volt-DC signal. Okay, version 4 of the J Plus series unit, they gave a method to work around this. All right, but you'd have to just check and see if you have a version 4. You can use the EH in line, but you just have to put an adapter on the inlet side of it that this one already has on it if you're going to use it in line. So there is the capability, the possibility of using that EDH, or you can use this EEH model that mounts directly on the outlet of the unit. All right, water coil performance. The easiest way to know what you can get out of these, how much heat am I going to get out of the small, the medium, or the large, the 60, the 90, or the 120. Well, the amount of heat is going to be 60, 90, or 120. Okay, so this, and they are used on the 60s, used on the smaller air handler, the 90s used on the medium air handler, and the 120s is used on the large 4 and 5 ton air handler. That rating is right in here, about 8 GPM at 180 degrees. You would revert to this chart if you're going to vary from that. But, just determining how much heat you'll get, you would use that nominal 60, 90, or 120 model number. All right, and those go. I mean, it's just typical piping. Of course, the water out's going to be on top. That's where your air vent's going to be. And the way that they mount onto the units is we remove the unit flange on the return side of the unit, and this heater mounts to the unit, and then the flange mounts to the coil, the hot water coil. Okay, so it's pretty simple. Just remember, though, I think it's about 0.11 or 0.12 pressure drop on these coils. Remember that we only have 0.25 pressure drop to deal with on the return end. All right, so that means we're never going to put any pleated filters on our units. And unless you have a lot of room as far as pressure drop goes to allow for the pressure drop. I've seen pleated filters at 0.36 by themselves. So where we take it out and we reduce the pressure by 0.36. It's crazy. No filters, super filters that stop everything, including the air. Don't use anything like that. But in this case, it's going to be even more critical because we've already got a 0.11 or 0.12 pressure drop through that hot water coil. So keep that in mind. We do have a drain pan, and that can be, it has like punch outs for threaded rod as well. Although I will say it doesn't allow that much room for the unit to sit in there in between the threaded rods. It's more of an attic thing, but it can be used. It has these channels here, and you can put unistrut in those channels and actually hang the unit. I did that. I just had to spread my 3/8 rods out a little bit to keep it away from the cabinet. Okay, so that's available. The good thing about this is that our units are not conventional in size either, so those fit our units very well. But the thing is, when you do put a hydronic coil on the end of our unit, our drain pan does not cover that hydronic coil. Okay, so it doesn't protect from leakage from the hydronic coil or fittings or whatever. So that's one thing. At that point, you'll be either making one or using a larger prefabricated drain pan. If there are any questions, by the way, David, if I'm not seeing, I'm only seeing my presentation here.
Ron, there's a couple that I thought we could take at the end. The other thing is we're having a little bit of problem with your audio. I don't know if there's anything. I've tried to see if I could fix it on Zoom. It just sounds like you're a little bit in the bottom of a pool. It's kind of like a bit.
Okay.
So I don't know if you can turn your volume up or if there's a lot of reverberation.
I'm in kind of a corner here. I appreciate you letting me know that, David, but I'm just going to move and up this thing on my lap.
That sounds better, actually.
Okay, good. I appreciate you letting me know that. And questions, should we stop at this point, David, or
well, yeah, let's do these questions. So there's one from Bob McAllister. Has SpacePak considered making an oval or round transition piece to make it easier to connect to the return duct? They've found, flex or round pipe difficult and time consuming to seal the oval flange.
Okay. You know what? ironically, I think they're looking at some different adapters for their units for return at this point. So they may be coming out with, with something that might make it easier for you to do. You can always use a plenum if you're doing multiple returns, and that doesn't have to be on zoning. It could be just, you don't feel that you're going to have adequate return on one floor or the other. You can always make a plenum and put it onto the unit. But I believe that they are actually working on some round adapters that you can pull the flange off and it will mount where the flange mounts, but transition to a round. So just look for that. They have considered that, and I think they're actually working on that as well.
And then another good question from Bob is, any suggestions for heating 2 levels? He's saying that aspiration only goes so far, and you end up with a lot of heat going up the stairs, resulting in a substantial temperature difference between floors.
I would use the zoning.
Say that again.
I would use the zoning, David. And
he's saying only zoning goes so far because the heat gets pulled up the stairwell.
Right. I've got zoning with 2 returns, so that helps me. I put an upstairs return in as well. That's really the best way, to use the zoning, because if you're cooling, I have a Cape Cod, for instance, and those are notorious for being hot. So are colonials. Being hot upstairs. So really that's the best way. If you can get a second return in there, that's better. That return, we're not going to shut the return off when we've only got the downstairs zone working. We're going to run that return at all times, so that helps to homogenize
some of that heat.
the building. Yeah. So yeah, that would be my suggestion. I wouldn't have any other suggestion. The zoning is going to heat or cool when there's a call from the thermostat. The only suggestion I would have beyond that is to actually use another return as well. That's going to help out.
Okay, and then we have a good question from A Peak. Will the hydronic coil work with an on-demand wall-hung boiler?
It should. I don't see why it wouldn't. Those get up to temp, almost immediately, I believe. And there's going to be, with that second thermistor that we had, it's going to begin heating that coil up. And when we get to temperature, then the control on that J plus will bring on the fan. So it certainly should work with it.
Okay, and then we have what's SpacePak's plan for refrigerant with the phasing out of 410?
I haven't heard anything specifically, but I'm sure that they're doing what every other manufacturer is doing right now. Testing with the new refrigerant. I forget the number of that new refrigerant, but I'm sure they're doing testing. It's mandatory at some point. So we're going to switch to a new refrigerant, and just like we did with our 410A.
How many 90s can there be on a main trunk line?
Well, we're going to cover that a little bit more in detail, but a 90, just to quickly answer that and then elaborate on it later on, a 90, a long radius 90 is 15 equivalent feet of pipe, of plenum, right? A short radius, and that would be the Smart Seal, David, where we've got that long radius. A short radius, I don't really have anything for that, but I would use 30 feet of equivalent pipe. So if someone were to be using standard elbow those, and we'll talk more about using Smart Seal versus standard pipe, and all of the extra sealing and insulating that you have to do. You know, we can go up to 200 equivalent feet of plenum, but we're reducing that by a T, which is equivalent to 30 feet, a long radius 90, which is equivalent to 15 feet. If they're using a short radius 90, I would use 30 feet for that. So, you know, chunks of 30 equivalent feet can reduce that 250 feet down pretty quickly. Okay. So it depends on what type of elbow and you know, the layout of the job.
And finally, can the hydronic coil be mounted on the supply side?
I would say no on that. I've never heard of it being mounted on the supply side, but I would say no, because we're at a high pressure on there, and I think that it would be detrimental to you know, to maintaining that pressure. There would be too much pressure drop on that, and not only that, but then we'd have to transition. You're not going to find a 9-inch round coil, so we'd have to transition up and back down. So all of that's going to be way too much pressure drop on the supply side there, where we're really trying to get as straight a run as we can and build up that pressure.
Okay, and then we have a request. I think kind of we were struggling with the audio at one point. Could you do a quick review on the trap again? Because apparently that was kind of hard to hear at the time you were doing it.
Oh, sorry, on the trap?
Yeah.
Yes. Yeah, the trap, if you look at the unit, the coil is closer to the outlet end of the unit. The trap is actually on the negative, I'm sorry, the coil is incoming, okay? But the, you know, and that's where the drain pan is. The motor is toward the outlet of the unit. So all that area before the motor, the blower, is negative pressure. So it's on the negative side of the blower. And what we want to do, what the blower wants to do, it wants to pull air from wherever it can, including up the drain line. So we need an adequate drain trap to prevent that from happening. If you get you know, above 0.25 static pressure, it's actually negative 0.25. But if you get above that, you can get to the point, if you go higher than that, where you're going to be pulling air up through the drain and not allowing proper drainage of the condensate.
Okay, and then we have another question. For heat pump applications, the HVAC outputs on the board don't have an R24 volt hot. Where do you pick up the 24 volt hot for the outdoor heat pump?
Excuse me. All right, that would be the 24 volt, the R terminal, the HVAC output. So you've got to the you know, the left on that board, you've got all of your thermostat inputs. All right, on the bottom of the board, the first set of connections there are the HVAC outputs. So the you know, our input from the thermostat and the 24 volts is it comes in through the thermostat, and you know, it's transmitted in the board, by the board, to that HVAC output, the R output, and you know, Y1, etc., are all on the bottom of the board there. So it's the HVAC outputs that are being connected to the outdoor board.
Okay.
There's also a B, a BO terminal, telling us, when we're switching over, the reversing valve, and probably a W. So.
Okay. Can you show a picture of the board?
I can. I'm just gonna slip on back here. Okay, so right where that arrow is, that arrow is actually pointing to the W2. That's that little workaround for running both heat and in DX heat pump and electric heat at the same time. But those outputs right there, where we've got, oh, see, okay, I think I see what he's asking now. There's no R down here. Okay, but we don't need an R down there because we're getting the 24-volt signal through Y1 and Y2. We've got a common, okay, right here, but we don't need an R down here if that's what he's asking, because we've got 24 volts through Y1. We've got a common for voltage return. We've got an OB, a Y2, and then a W1, W2 here as well.
Okay, so that's go on. What we're seeing is the defrost controller requires 24 volt to power it.
Yes. Okay. So this DFS here is that's where the W, typically it's W on a heat pump coming back up to here. All right. So, but we don't typically have the common coming back from our heat pump. What we need to do here is grab a common off of our thermostat, or off of this connection. So we just need to grab a common from someplace else. That's all.
So from Tad Hill, he's saying, don't we need a dedicated 24 volt for hot?
Where we need what was that?
Doesn't the heat pump outdoor unit need a dedicated 24 volts for a hot call?
For a what call?
For a hot 24 volt.
So for heating. So for heating call.
Yeah, presume so.
I don't. I'm not sure what for specifically. I mean, here's the defrost. We've got heating on the compressor is going to be Y1, whether that's going to be energized, and C, which is common, and OB, which is 24 volts as well. So we're going to be energizing Y1, and we're either going to energize or not energize OB. The board will know that that's in the setup to either leave the reversing valve as is, or change it for changeover in the heating, which would be a B. Yeah, I don't know. That's our 24 volts right there. Now, as far as a W signal, that would come back through defrost. We'd have to grab a common. We're going to end up doing that because mine and the ones I've seen out there didn't have a common coming back with the defrost signal. So we take that signal here at TFS and we just grab a common. We just need that for voltage return. Okay, so we grab it off the thermostat or off of here.
So there's quite a chat, Ron, if you want to look at the chat, there's quite a chat going on about what you're saying.
I'm gonna, you know what, I'm gonna keep on moving.
Okay.
And, you know, I apologize, guys, but you know, once you get to the wiring diagrams, you know, I don't want to. We got to move through all this information, and we can always talk about the specifics of your job and how to wire it later on. So I do want to keep moving, and you know, yeah, we'll find the way to wire your specific job at the point that you're going to do that. That's not a problem. All right. Anything else on there, David?
It's still more debate about the 24 volts and where to pull it from. So hopefully when you get to the wiring diagrams and everything, we'll answer that. And it's better if you put it in the Q&A rather than in the chat, because we can see if we've answered the question or not in Q&A. If it's in chat, it can get lost with all the other messages that people post up.
Yeah, the 24 volts is coming through Y1. There are like 4 wires, and I've seen this on a couple of heat pumps. There are only like 4 wires. There's not an arm going down to, you know, an R is 24 volts. But we have 24 volts already going to the outdoor unit. We've got a Y. We've got an L or B if we need that at that particular time to tell the reversing valve when to work and heating or cooling. We've got a common, and we've got a W, which is you know, is going to relate to heating. There's really, in mine, that's really all I have. And that's all I've seen in the field. I don't know if you need an R because you're getting 24 volts through Y. So anyway, but yeah, we'll see. They, you know, in the downloads is the J Plus series installation manual. So, and it's good to have that anyway. Feel free to download that and take a look at the wiring diagrams in there. That might, you know, that might answer any questions.
Ken will answer your question a little later, because I do think we need to move on, but we will answer it at the end.
Right. Okay. All right. So let's scoot and let me get back down to where we were here. Okay. All right. So the return, as I said, you know, we've got less return, but we need every bit of it. All right. So we've got 250 CFM per ton. That means that each BTU is more critical. It's 1/250th of the return as opposed to 1/400. Excuse me. So we're more critical on the return. But because we're using aspiration to move that air around the room, it's less important that we would have a return in every room. That's why a centrally located return works well for us. All right. As I mentioned earlier, the equipment can fit through the return, and the you know, the filter grill would go back in its place. Okay. Make sure that there is enough room underneath the doors for return to go into that common area that we're returning from. Okay, so again, you know, if you get the return down and you have adequate return, you're going to need that, and you'll save yourself a lot of problems by not having an adequate amount of return. You can actually feel when you pull the filter out, you know, you can almost feel the difference with the air flowing through the unit. You're really holding it back by having a pleated filter in there or inadequate return in the system. All right, air mixing versus air change. We talked about that, less air volume, and central return. So I'm going to skip through that. All right, size return in each location for less than 500 feet per minute. You're not going to find filters that are rated above 550 feet per minute anyway. Size return in each location for a total of negative 0.25, 1/4 inch of static or less, including the filter. Install at least one 90-degree elbow on the return. All right, so sound travels in a direct line. This 90-degree helps to attenuate that sound, because now it's not traveling right to the filter grill and being heard outside. Oops, sorry. Okay, the return box must be lined with sound attenuation material or insulation if you're making your own return box, return plenum. Our return duct material, the 10-foot section, it's an odd size, and not only is it an odd size, but it does have those sound attenuation material, cloth sound attenuation material, the same that you see in the sound attenuators. So that's another advantage to using our duct. You've already got sound attenuation built into that. Size transfer grills, okay, for underneath of the the doors in bedrooms, for instance. Make sure that there's room underneath the doors for what return we do need to make its way into the area that will be used for a common return. Okay, there's that 90-degree bend. All right. Typically we're up on a platform to give ourselves enough drainage. Okay, and if you look, the return duct there, we've got 15 inches, 19 inches, and 24 inches. So 15 and 19 are odd sizes, but again, we've got the sound attenuation there. Our filter grill is that same size. That gives us the maximum in that oval that we want to put into there. You can make a plenum. You can make an adapter if you want to use 16 inches or 20 inches. Sometimes 24 inches is kind of large and hard to fit. So, you could put an equivalent amount of square inch of area, and split that into two returns if you wanted to, and put a plenum box on the end of the unit. So that's possible as well. Here's a return from a floor grill. Looks nice. All right, multiple returns. Here's how that works again. Unfortunately, we're at 440 here is what we're showing. Okay, so we're showing the minimum airflow. You want to try to be at 250 per ton, so we'd be at 500 right here. All right, the way this works, this was initially came from zoning. All right, and the way it works is if you have two returns, then you're going to take a look at how long each return is individual. If you had one that was 10 feet and you had one that was 15 feet in a 2-ton, then you would use a 9-inch duct. Okay, but I'd probably up that to 10. And here you'd already have that 10 right there. So you might want to use both 10 with respect to that. It's going to be hard to find like a 9-inch flex. This is the only place, by the way, the return where we're going to use flex on our system. We don't use flex collars. We want a rigid duct installation on the plenum side. But on the return side, we could use flex duct. We just have to use the right size flex duct. Okay. So here on a 2.5 ton, if we had one that was 10 foot, here we go, that's 10 inch we could use on that. And we had a 15 footer, it comes out to 11 inch. We'd probably up that to 12 inch All we're doing here is we're making up for the, you know, the extra length and the extra pressure drop that we'll get from that length. Okay, so not too hard to understand. Multiple returns. Here's one with 3 returns, right, and a plenum on it. Incidentally, this is an older unit where we used to be able to come up. We used to be able to convert a horizontal unit to a vertical unit, but when we started putting EC motors in there, the motor head didn't give us enough room and didn't quite work with the, you know, with doing this. So if you see this in the field, you would just want to put a vertical unit in place of that, or exit horizontally and turn vertical. This is also an example of a side shot. We'll talk about that. And that's it in that picture. Okay, we can put an HRV and ERV in there. And you know, this is how you would do it. Okay, you're not really interfering with a full flow here. You're you know, you're going to have some pressure drop through here, but you're going to maintain adequate airflow through, and you know, pick up what you can as far as air from the HRV or ERV. All right, so you can use that. All right, so main trunk, 6 to 7 outlets per ton on AC systems only. 6 is going to be noisier. 6 is going to be more often used in a retrofit application. You want 8 on a heat pump system, or, you know, as close to 8 as you can get on a heat pump system. You're getting 2,000 BTUs per outlet. Fully rated outlet and cooling, 3,000 heating. All right, outlet placement in a room. You know, we could talk about that. It's kind of the same common sense that we would have in a conventional system too. We don't want to put it over somebody, where somebody sits, over grandma's rocking chair, over a bed, over a curtain or something else that's going to move around. So common sense there. All right, we do need to do a room by room load calc. Otherwise, we don't know how many outlets to put in a room. All right, and that relates directly to this 2,000 and 3,000 BTUs per full outlet. And we'll talk about full outlets as well. All right, we'll talk about the best length of a duct run, maximum length of a duct run, most common duct mistakes. All right, again, I talked about this 250 feet of equivalent length of 9-inch round. If all fittings are long radius, the system is sealed to stop duct leakage completely. All right, so it has to be a sealed system. And if you're going to use, I'll cover that now, if you're going to use standard galvanized pipe, you have to seal every seam, every joint, and every seam in a 90-degree elbow as well. Plus, you're not going to find long radius elbows in, you know, standard galvanized pipe. Fittings reduce the length by 30 feet per teeth, 15 per elbows. This is a long radius elbow, so, you know, again, use 30 feet for a short radius elbow, and you know, work backwards from 250 feet, and that'll give you the maximum length. All right, so we recommend Pierce-Phelps stocks Smart Seal. Okay, it's a gasketed spiral. It seals to it'll seal to, I think, 10 inches if I've got the spec on here of water column. It's hard to get them apart. That's how well it seals. You do have enough room on these, enough lip on the connector, for instance, where you can, you know, if you're in a spot where you want extra structural integrity, you can put some screws in, but for the most part, these will seal themselves without any screws. I also tape them. It's a good idea to tape it as well. That provides rigidity and also seals it further if there's any kind of leak through there, dirt in there, on the gasket, etc. All right, so less energy loss, more plenum, less 2-inch duct. Okay, so we always run more plenum, and if we need to, because we've got that 250 feet to work with, we run more plenum, and then we run less of the 2-inch duct. That's where the real pressure drop is, in the 2-inch duct, and those are critical to keep it at 15 feet or lower if we can, or to compensate for longer runs. So, always put some more plenum on to get a little further down if it's going to keep your 2-inch duct runs shorter. All right, static regain, replace the static reduction. We talked about that. Simpler rules for design. We're not reducing as we go. We're running 9-inch round or 8x8 square all the way down, putting a cap on the end. All right, so easier installation. These are very easy to install. You just have to know, the things that we're covering today. All right, plenum requirements and allowances. We're going to talk about all those different things. We need 64 square inches. Okay, that can be 9-inch round, 8x8 square, 6x11 rectangular. It can be 3x21, but you better brace that because it'll be, tin canning. When the pressure builds up in it. Anything with 64 square inches, even a triangular duct will work. Smart seal pipe fittings. We talked about that. Gasketed spiral, up to 10 inches water column, leak resistance. It's hard to get them apart once you put them together. All right. So this is really what you should use here. It comes with insulation as well. You'd have to buy that separately with, standard galvanized pipe anyway. All right, completely leak resistant. All right, here are I'm picking up the pace a little bit here because I do want to get all the way through this. 4 main configurations here. The shotgun. All right, and you shoot a shotgun. It doesn't take a left and then a right and then another right. Okay, but we call that a shotgun because it's one continuous line from the beginning to the end. It doesn't tee out anywhere. Horseshoe is very common. We've got 2 branches on each side, and we've got some rules that go along with all of these. Here we're going to talk about the 60-40 rule for T's. Side branch, we've got what we call the 30-70 rule. You're not going to get any more than 30% of the air to go down this side branch. And perimeter loop, the great thing about this, if you can use it, the pressures equalize, and it's not so critical as to what you have on this T. So we can kind of throw the 60-40 rule that would be applicable for the horseshoe. We can kind of throw that in the trash because we're equalizing the pressure all the way around that loop. Again, always run them in less 2-inch duct. Never have more than 60% of the takeoffs on one side of a T. That's the 60-40 rule, 50-50 to 60-40. Never have more than 30% of the takeoffs on the side branch. We can have less, but not more than that. Minimum plenum length is determined by really basically all the clearances that we need. 18 inches from the outlet of the blower before a 2-inch takeoff. So we don't want a 2-inch takeoff on that 18 inches. 18 inches from a fitting before a 2-inch takeoff. So if we have an elbow, we want to wait till 18 inches before we start having takeoffs. 18 inches from the end cap before a 2-inch takeoff. So, up from an end cap, we want 18 inches, minimum of 12 inches. 6 inches offset between the takeoffs, minimum And when you figure that you've got a 2-inch round circle on two sides of that, it's really only 4 inches between. So 6 inches on center between takeoffs is the minimum. Leave more than that, you're better off. So that's just showing the minimum right there. So with straight pipe, you can have a short plenum, even at larger tonnage outputs, because we don't have all of the fitting clearances that we have just above. All right, so 18 inches from the blower before an outlet, or before fitting, 18 inches up from an end cap. All right, shotgun, straight run a duct. Okay, straight run without all of these elbows in there is also considered a shotgun. Straight on down. All right. Okay, no outlets on that 18 inches, and it is 18 inches before the fitting, a T or an elbow. All right, we got the 60-40 rule, no more than 60% capacity on one side. Again, the same applies with the minimum of 18 inches before any fitting, including a T that you're doing a shotgun off of. 30% maximum capacity. It doesn't have to be 30. It can be less than that, but maximum would be 30. And 70% down the main trunk, maximum capacity. All right, there's that. Again, that was a good side shot picture right there. Okay. All right, this is really like a horseshoe. All right, but we're just going straight on each side. This is done often. It's still considered a horseshoe. We've got the 60-40 rule on this that we have to adhere to. Okay, we're just not making the turns on here to make the ends of the horseshoe. All right, same thing here. All right, we're going to have 60-40. Well, we don't have it coming up, but 60-40. We can do an H system. We'd have a 60-40 rule on the T in the middle, and we'd need to be 18 inches in the center here. We'd have a 60-40 rule on this T. We couldn't have any more than 60% on one side of that T versus the other, and we'd have the same over here. One side of the T versus the other, we'd have to be 40-60 or less. Okay, so for each T, we've got that split that we have to contend with. Excuse me. All right, perimeter loop, as I said before, it equalizes. So this is a good way to do it if you can do it this way and not end up with too much duct. These are a couple of things that were done wrong. We didn't come out of this unit with 18 inches before we had a fitting. Okay, this was a vertical unit. Same here on this unit as well. This is another thing on that one job is they came outside, ran down, and didn't adequately insulate that that job. So that was not a very good job that they did for other reasons as well. Can we use a smaller size duct? Okay. We get asked this a lot because older systems used 30% less CFM than we use today. Okay, so today we use 9-inch duct, and back then they used 7-inch duct. All right, in the retrofit section, you'll find these of the installation manual. Okay, and there's one for download as well. In that, you'll find these, and I hope we have I don't know if we have it, but in there, it basically tells you that these pictures, a lot of times guys overlook that, these pictures are in relation to the 2430 air handler. Okay, it's recommended for the 3642 or the 4860 to actually change all of the duct to 9-inch. Okay, but here on the 2430, okay, basically what we're doing is we're on a shotgun, we're changing out the first 40% of the outlets to 9-inch. And then we're figuring, well, we've got less volume at the end here, so we're okay with 7-inch. So again, where to find this information is in the installation manual. All right, on a horseshoe system, all right, we're basically changing out through the T and the elbows, and where we reduce down to the ends of the horseshoe, where we're using the 7-inch round. Okay, if you can't get that out, you're always better off using 9-inch. Okay, here, same thing. This is the side branch. We're changing all the way through the T to 9-inch and reducing afterwards. All right, so again, this is on the 2430 air handler. All right, the takeoffs go into the plenum using a 2 1/8-inch hole saw. This is a pair, and this is available. These are reverse acting pliers. These make the installation of the clips that come in the kits a lot easier. Okay, so there's a gasket that goes in here, and there's a gasket that goes in here, and the outlet seals against that gasket and provides a sealed connection for the quarter turn quick connect fitting that we use. Okay, so you'll see that fitting right there. All right, that's quarter turn, gasket in between. Get the pliers, your hands will thank you at the end of the day, and get a 2 1/8-inch hole saw, which is what you'd use to install these. Use all 4 of the clips. If you use 2, you could be rocking on there. But make sure that you use all 4 retainer clips provided on the takeoffs to make sure there's a solid seal on that gasket. Here's how the plenum takeoff kits come. They come in sets of 2 or sets of 5. Okay, usually that's 7. Right, but you may have to, if you have long runs, you may have to get a few more of them. Another pack of 2, another pack of 5. Right, they come in curved for round pipe, or flat for duct board or square pipe. All right, so we have R6 or R8 as far as the R value. As far as we're concerned, R6 is fine, but if you're outside of the envelope, your inspector might want you to put R8 in there. R6 is certainly easier to get down through a wall, and again, it's only 2-inch, so there's not a lot of surface area where you have a loss. But we make R8 because some inspectors are going to require you to use that. This is the tubing machine down in the Farmville plant. All right, it's made in a continuous 100-foot loop for R6, 75 for R8. This is all aluminum. There's no spline in here. It's made. It can actually be cut with a butter knife. That's what you would want to use to cut the 2-inch tube. But it's the easiest way to do it. Not a butter knife so much, but maybe a bread knife. All right, something sharp enough, maybe serrated. Easiest way to cut these, and they'll show you that in the YouTube videos that SpacePak has online as well. All right, 6 to 7 outlets minimum per ton on AC. We go into some, if you're above 5,000 feet, 6,500 feet, you need more outlets to compensate for that. 7 to 8 outlets minimum per ton on a heat pump due to higher coil pressures. 2,000 BTUs cooling, 3,000 BTUs heating. Okay, and I think we have actually done that slide. All right, this right here is an important slide. Okay, this chart is in every installation manual. And basically what it shows, we talk about outlets. Okay. A lot of times when we're looking at somebody's having problems with a system, they'll tell me, well, I got 18 outlets. It's 2.5 ton, I got 18 outlets. Well, the next question is, how long are the 2-inch tubing lengths on those outlets? Because we derate the outlet by the amount of 2-inch tubing that we have on it. So he doesn't, if he's got long runs, he doesn't really have 18 outlets. He's got something less than that. All right. So shorter than 9 feet works with a duct orifice. Um, we call it a balancer. But the shorter they are, the louder they are as well. Okay, so keep that in mind. Longer runs work if more runs are added to make up for lost CFM. We got the 10% rule. After 15 feet of supply run, you lose 10% for every additional 5 feet or part thereof. Loss of CFM and BTUs. Okay, so 15 feet long. Okay, this includes the 3 feet of sound attenuator, which is on the end of every run. So you cut additional 12 feet. You'd put the fittings on that, and you'd have a 15 feet total run, including the sound attenuator. That's a factor of 1.0. That's one fully opened outlet. If you have 20 feet in length, including the sound attenuator, all right, you lose that 10% for that extra 5 feet. You only have 0.9 of an outlet. 25, you've got 0.8 of an outlet. 30, you've got 0.66. All right, so these deficits add up, and if you have a lot of long runs on a job, then you've gotten less outlets than you thought you had and that you need. All right, so need to be aware of that. Minimum 4-inch turning radius. Okay, basically our fittings are quarter turn. We screw these in. Quarter turn is that the other end of this takes a quarter turn to for a tight seal to go onto the end of this. So you cut your own length. You put the quick connects on in the from the installation kit, and then a sound attenuator would go on the end. So basically, if this was the duct that you made up, the sound attenuator would screw right onto that. The 2-inch outlet would screw right onto the end of the sound attenuator by that quarter turn twist, and that would be a tight seal. All right. So you crunch down a couple of inches of the aluminum, and then screw the fitting on. Again, they've got a great video online, SpacePak does, where you can see Ken from the factory putting these together. So it's definitely recommended that you take a look at that. All right, the insulation, the extra insulation gets tucked into here, and you put tape around that just to keep everything tight and secure. Make sure the insulation doesn't pull back off of the aluminum tubing. Here's the sound attenuator, 3 feet long, comes with the installation kits, goes on the end of every run. All right, if you don't have these on there, it's going to be noisy. You need to have these on there. Think of it as a muffler, if you will. 7 outlets per ton at 250 CFM. Again, 2,000 in cooling, 3,000 in heating. I have these changed to reflect 250 CFM per ton. 500 feet, 2.5 ton is 625, etc. Okay. 10. I thought we took that off. Nobody puts extra outlets on, but yet you might have to if you do 3 zones or 2 zones and the zones aren't the same size. Okay, but I don't normally show this outlet because it costs a lot of money to put extra outlets on and pay for all of that extra tubing, so you wouldn't be doing that anyway. All right, the CFM per outlet,
this is not really on as far as the numbers, but this gives you a good idea as to the differences in length and the differences in plenum pressure and what those differences cause. Okay, so here you're less less pressure here, more pressure here. We've got less CFM and more CFM. So we want an adequate amount of pressure. We just don't want too much pressure, or we're going to be pushing the air out too quickly and working too hard with the motor. Okay, if we go up in length, all right, so we go from 10 feet, right, to 15 feet, we're going from the 40 CFM that we want down to 33 CFM. You get down to 22, 23 CFM, you start losing the velocity out of the outlet and the aspiration effect as well. Okay, these are the kits. They come with sound attenuators, connectors for the tubing. You've got your outlets. You've got winter shutoffs for cooling only systems. You've got clips, screws, and you've got the balancing orifices. You might want to use one of those in the typical off the dining room, downstairs bathroom that's really a closet. But you really don't want to use these anywhere else. You're best off just seeing how you do as far as the number of outlets that you put into a room. The other thing is, if you do one of these, use one of these, mark the duct with which one you used. Mark the plenum, so if somebody comes by, another contractor or another guy from your office, he knows what's in that system. He knows that he's not getting much air out of the end of that thing because he's got a balancing orifice in there. So mark it right on the plenum duct at the takeoff, the plenum takeoff, which is where these go. Mark it right on there. Okay, these come in quantities of 2 and 5, which is conveniently 7. We talked about that. You don't want to mount those balancing orifices here. It always actually gives that same pattern. It gets dirty and it's pressure drop and they're noisy. All right, so these actually go back at the plenum takeoff. All right. Again, outlets in any direction, placements in a room. Don't block an outlet. Don't put it where there's going to be a piece of furniture. Common sense. All right, room by room load. We went through that, and this example here covers that. I'm going to go through this quickly. All right, because the whole point of this, or the largest point, is that we kind of do this exercise for both heating and cooling. Okay, and how many how many BTUs we put into a room versus our heating and cooling loads. So we look at both our heating load and cooling load, and for instance, here in the master bedroom, we have a heating load of 6,100 BTUs. We're getting 3,000 BTUs per full outlet in heat. All right. So that basically, if you want to call the 100 BTUs close enough, that would be 2 fully open outlets there. In cooling, we've got 2,000 BTU. We've got 4,400. So you'd probably, from a cooling perspective, want to put 3 of them in that room. All right, so that's really this exercise kind of goes through that, and it says that how many outlets you want to put in the room based on the larger number of outlets from either the cooling or the heating BTU load, and how many outlets would be required for that load. Okay, And then we want to look at our total outlets and say, well, you know, we've got a 2-ton system and or 2.5-ton system. We've got 13.65 outlets. And you know, we would want at least 15 outlets. So here we go, we have 16. All right, so in here we have 16. So we've got that covered. We've got, you know, how many outlets per tonnage covered as well. You want to check that too. All right, so I'm going to zip through the rest of this here because it goes through that same exercise a couple of times. All right, there are different ways to do the system in the same house. Okay, so we've got the same outlets, and you know, here we're using, you know, a different type of layout. Excuse me. Depending on which you know, which system we want to use, or we feel is the best to use for that particular job. All right, so there are wood outlets too. The new wooden outlet is actually just round. All right, it doesn't have this part here, so there's a different installation. So you wouldn't get that square part there, and all of the outlets now have the quarter turn quick connect on them. All of them are also unfinished now. It was just, you know, they would ship finished outlets out, and they wouldn't quite match the floor that the flooring guy would put down anyway. So you put them down, you do flush mount, you can do a surface mount. They're available with a 2-inch hole or with a larger grill, if you will, that gives the same open area as the 2-inch hole. We also have a linear slot diffuser. They are not cheap, but they are very nice looking and aesthetic. They're in a 90-degree format as well. And here's your standard outlet right here. As you can see, we're on the end of an attenuator, and we're also using the prefabbed 90-degree there as well. Okay, let's move on. All right, so this would be a 4-inch hole saw. All right, for the ceiling. Okay, you can see the screws that we're going to use to you know, to install this. So we hook the sound attenuator right onto this, and then we put the screws that are included in the kits on there. Here's that quick connect wall elbow. We have rough fin plates, and we have quick connect extensions for thicker walls, an old stone wall, for instance. All right, here's an application where we've got wood and we've got standard outlets, and we have them in a large area, so they're up high and down lower as well. Here's the linear diffuser, a couple of them. They look good, they're aesthetic. Kind of depends on the height of your hall. This is saying, you know, center of the hall, but this is a really high hall. If you have a shorter hall, you may want to put them a little bit off to the side where you're not blowing directly on people walking underneath. Here are some outlets. These came up through the, you know, through the floor. And, you know, obviously the wall was open when they put them in. Here are some through the ceiling. Okay. There are 42,000 BTUs. That's 21 outlets in this one room here. You know, that's one of the considerations for using this equipment is that, you know, they're 2-inch tubes, but if you have a large load, you're going to need a lot of 2-inch tubes. Here's a soffit application that turned out nicely. Here's a commercial application. 4 to 5 outlets per ton are going to work here. You know, we don't have any tubing on here. We're just blowing straight. So it's a good way to quickly and easily heat a you know, commercial area. All right, we can zone. All right, and you know, we can do either 2 or 3 zones. Now, when we, sorry, I'm gonna make sure my battery doesn't run out here. All right, so when we do zoning, we, it's 2 or 3 zones, and we want to make sure that we have an adequate number of outlets for each zone. And there's an equation that we use, and we'll show you that in a second. All right, but we always use a staged, as in 2-stage or fully inverter condenser for zoning. Okay, we don't use a single stage in zoning. The smallest zone must be the same size or larger output than the lowest turn down capacity of the compressor being used. Okay, so if we have a 2-ton and the first zone is half of that 2-ton, then we want to make sure we have turned down to at least 50%. Okay, so that's really what we're looking at there. When using multiple zones, the controls on the J series air handler will allow you to match the airflow. You can run it by pressure, or you can just run it at a lower percentage of speed to account for running 1 zone versus 2 zones. All right, so you just have to be careful about how you lay out those zones. All right, never use an air bypass. You're going to freeze our system. You could freeze a conventional system, but you're going to freeze our system, and it's not going to work right. It's actually going to go off on the freeze control. All right, so here's the equation. It's you need to do 3.5 outlets per ton per zone. Okay, so this is on an air conditioning. So for heat pumps, that's 4 outlets per ton per zone. Now, if you have 2 zones here, you're going to have 7 outlets per ton because it's per zone. So the takeaway here is that if you're using 2 zones, if you're doing 2 zones and they're the same size, or you can make them the same size, then you're going to have the same amount of outlets. If you're using 3 zones or 2 zones that aren't sized the same, then you're going to have to add outlets, and how many outlets you add is going to be determined by using this this equation here. Okay, so keep that in mind. This chart is, and it's in the downloads for today, in the tips, what we call the tips brochure. All right, so if you look here, all right, 2 zone number of outlets, in a 2-ton system, that's 7 per zone. You come up with 14. Well, you're going to have 7 outlets per ton anyway. So, this shows right here that if we're doing 2 zones and they're about the same size, you're not going to add any extra outlets. That same 2-ton system, if we have 3 zones, we're going to have 21 outlets. Okay, so just keep that in mind. It's an easy way to remember that 2 zones is as pi. 3 zones gets a little bit more complicated. We can go more into the zoning when you get a job that has zoning. There's not a whole lot of room to cover that today as far as time. You in this 2.5-hour format. Here, basically, what you would end up doing is adding more outlets to the smaller zone. Okay, so that's where that comes into play. Here's that same chart. Okay, and I do want to point out that the other one I changed. This one's a graphic. This 10 to 20, after that, really should be 20 to 30. So that's wrong right there. And compensate for instance, when I did my 2.5-ton system, I used this here because 2.5 tons was 625. I wanted 250 CFM per ton, so I used this column, and then I bumped up here, for 12 because there was no 11. So just keep that in mind. Here's actually my house here. The other thing I did was I had a little bit less zone or outlets upstairs in my zone too. So what I did was I took my first floor dining room outlet and I took the damper off of that. I used the dampers that go on each and every run, not in the 9-inch duct. So I just didn't put a damper on that. So that particular outlet works on either zone. Okay, so what that did was it made my zones a little bit more even anyway, 9.22 versus 10.8. All right, I ended up with 7.6. And my system works fine, but it's an inverter system. So I have more than 7 there because I have that heat pump. I think these, okay, for zoning, all right, we can put the zoning dampers in and use sort of an H system, or we do have zoning dampers that will go on each and every one of these runs. I did a shotgun system, and that way I could put my zoning dampers on whichever run was going to what zone that was. Here's an exercise that you need to do, and I have in the handouts using a manometer or velometer basically to determine how many CFM you have. It's 0.0218, okay, as the square feet of a 2-inch hole. All right, so feet per minute velocity, if you can only measure velocity, and your velometer doesn't measure in CFM or calculate to it, then you would use feet per minute times 0.0218. Again, that's in the handouts. You have to do this basically. This is the only real way to find out exactly how much air you have coming out of your outlets. All right, and if you have a problem, or in my case, I use this for design as well. Then you basically have to go and measure every outlet, and here we converted to CFM and came up with how many CFM that we had for a particular system. In my system there that we looked at, you can see full outlets, this column full outlets, the second from the end here. My living room outlets on the front side of my house downstairs, I went up and over my upstairs, basically my roof line, because it's a Cape Cod, it's got knee walls. I have 27-foot runs, but I calculated them at 0.76, and therefore I have more runs to make up for that reduction. All right, so we are just about done here. Running a couple of minutes over. I apologize for that. So these are just examples. There's that 0.0218. I used to figure that out till I got it in my head, but there's a document that shows it. This was being out on a job, and they were way short on outlets. The way to determine that is to take the lengths of the 2-inch tubing, compensate by that chart, and figure out how many fully open outlets you have. It's kind of a road exercise, but that's what you need to do. Again, here's that picture. If you want to take a shot of that, I'll come back to that. We're finished here, and we appreciate your time. We'll get you loaded into the system at SpacePak so that you're on their list of certified installers, and we do have that sheet. If you don't get that sheet for any reason, you know, feel free to call David, email David. If you took our in contact information in the beginning, contact us and let us know that you need the sheet to sign up to be on the dealer locator. It's a separate sheet, and we'll make sure that you get that somehow. David,
So,
do we have any questions? Do we want to answer?
There's an ongoing kind of discussion around that 24 volt and wire and how to best use it. So what I've done is I've sent you Ken's contact phone number. So
Okay.
I think that's probably best served as a one-to-one type conversation. Ken, I hope that's okay.
That's absolutely fine. Yep.
And also we will package up some useful information when we sort of send out the form. We'll pull out the kind of best practice in terms of length of runs, a number of sub runs off the main ductwork, just for useful stuff to keep in the truck. Thank you, Barbara Inkowski. That was a great suggestion. And again, it's not complex stuff, but there's a lot of stuff to cover, and sometimes it takes us a little longer than we hope. But thank you, Ron.
Yeah.
And thank you for everyone's interest, because one of my barometers of this is how many questions we get, and again we got a lot of questions.
And keep in mind, guys, we've had very good, not that we haven't had any supply chain problems, but we've had very good lead times, and currently we're good on our 2-inch supply runs, and a relatively low lead time on our equipment. Plus, Pierce Phelps has a great inventory of it as well. So we're available. If you're having problems getting parts and pieces out there, we're available. It's a great system to install, and now you know how to solve. I thank you all for being here. It's sure a lot easier to if we need to discuss with somebody who's been through the training, but for you guys to do it right in the beginning, so you're not caught somewhere in the middle. And and we also realize that you went through the class. Maybe you're not going to install one of these for a while. Feel free to call us and just say, hey, I went to the class. I just want to brush up a little bit and have a couple of questions for you. We're happy to do that. Very happy that you come to us ahead of time and try to get the job right when it goes in. So thank you, David. And
no, our pleasure. Thank you, guys. I'm going to tear it down.